Hello, welcome to Everything Distributed. Today we are going to talk about attack on DNS system domain name service, and it is based on a very nice book by Kevin. So last time we talked about like DNS system, how it is similar to the library format. And the idea is that you need to get the IP address of the website that you want to visit. So you go to DNS resolver, it will contact all the server to get you back the result. But then if the DNS resolver, the librarian, or any of the server is down, then as a user, actually, you have nothing to do, nothing can do because you only have the website name, but you don't know the IP address, so you cannot go to the website because you don't know how to deliver the packet there. And then there are two very popular DNS attacks. The first one is called spoofing attack. Then the second one is like DOS attack or DOS attack. And then as a DNS is a distributed system, and that is very complicated. So you have a lot of attack surfaces, meaning that different points, the attacker can try to launch attack. So you could have a compromised DNS server, or like even if your user machine is compromised or malicious, or you can have a local DNS resolver that have the back cache route you to a different website, or that you have some malicious DNS server. So now let's look at one very simple idea. So now suppose you want to visit google.com. This is the correct one. And then the other one is a malicious one that try to hack into your systems or try to steal your information. So what it can do is that, remember that the user need to contact the DNS resolver. So it's sent at google.com. Please tell me the IP address. Then the malicious attacker can try to intersect this information and then say that, oh, now the user tried to visit google.com. So let me spoof fake the DNS return result and say that, hey, here's the IP address, which is a fake one. Then the user, if it doesn't know that whether it's from a real DNS resolver, you said, okay, now I'm going to visit this fake website because I thought that this IP address is real. Then the attacker, the malicious, the website can launch a new type of attack. Okay. Then the other possibility is that the attacker can try to attack the DNS resolver. So in this case, remember that DNS resolver need to contact the other more complicated part of the DNS system. So again, it's the similar attack. The malicious attacker try to intercept or eavesdrop the request, and then you get the DNS query, say, oh, now you want to go to google.com. Okay, I will return a fake or forged IP address. And then why this is bad? Because that the DNS resolver, there's a cache, right? So that the cache will be polluted. And then that's what we call the DNS poisoning or DNS cache poisoning attack, because that all the other users that try to contact this DNS resolver will route to the bad website, malicious website. And then that's why the attacker can affect lots of the user, not just a single one like the slide before. Okay, so that's the fundamental of the how malicious attacker can launch this DNS spoofing attack. Now let's look at the DOS attack or DDoS attack. Actually, back in 2016, there's a large scale attack on the DNS server, which is DIN, and then it's affecting lots of websites, especially in the northeast area of US. And then you can go to Wikipedia to check the list of the website that's that's effective. And then the main reason is that the DNS system, some of the machine, it that kind of blow up because of DDoS attack. It cannot handle the workload, and then all the normal user cannot get IP address. And then just in November, actually Cloudflare just stopped almost at 2 terabits per second DDoS attack. It's multi-vector attack, meaning that the DDoS attack tried to attack that multiple points of the internet. And then one of the key part is trying to use a DNS amplification attack, meaning that it sends lots of DNS requests, and then the DNS resolver will need to try to resolve lots of the DNS requests. And then that's one of the very common attack for like this DDoS attack. And then there are actually lots of more advanced DNS attack, like tunneling, hijacking, or like phantom domain attack. Then I encourage you to check this website. It tells you like what each attack means. And now let's get back to this cache point sending attack, and then actually that the similar logic applies to other more advanced attack. So the core reason why that right now the DNS system we have is that vulnerable. It's because that if you remember from last video, the way we address or that to solve this DNS request is that nothing is actually encrypted, so that we don't really have authenticity. So like when the DNS server responses, you actually have no idea it is from a valid or authentic DNS server. That's why this cache point sending attack or the DNS spoofing attack is possible. So there are several solutions that can help address this. The one is a domain name system security extension, DNSSEC. The idea is that the server need to use digital signatures. So when you contact this, you can be sure that the server that you are chatting with actually is authentic. And then the other one is similar, but that is using the security at a different layer, which is a transport layer. Then idea is similar, but you use a different approach to ask the DNS server to prove that it's authentic, to provide or prove its identity. So both of these solutions rely on the PKI, meaning the public key infrastructure. So you need to have public key, private key in order to make sure you are talking to the right person or right server. But then the chain of trust, meaning that who can verify one's identity, is different. So now we have the solution, and then actually that the big company, they are trying to slowly adopt some of the solution. However, this kind of solution actually is non-trivial. Then if you have used Slack, you might remember that back in September, there's a huge kind of issue or unavailability for Slack. Then you can check the Slack status report, and then actually that instance was related to DNS operation. Then one person from the DNS kind of community said, hey, Slack development team does did something weird. How do I contact them to resolve the issue? And then just a few days ago, the Slack engineering team released the kind of incident report to try to document and learn from their mistake. And actually the issue is because of they didn't do this DNSSEC rollout correctly. And then in fact, they tried 3 different times, and then all of them fail. And then the issue that caused the unavailability of their service became larger and larger. And here is some I think the key points from the article or from the blog post from the Slack team. Then the idea is that they actually identified the issue relatively quickly, but they were not expert in DNS, so they misconfigured something, and then they tried to roll back. But then remember that this DNS system actually is a complicated distributed system, different entity, like own or different manager owns a different part of the system. So that some hours into the incident, the SLEC team actually try to react very quickly. They contact IPS, they contact the DNS servers, the service provider. So that most of the SLEC, that kind of availability issue was resolved. But the issue for this distributed system is that there's always long tail of a user. Their resolver or their provider are smaller. Then remember that this resolver has this cache. Then the cache is not done or not refreshed correctly. Then it's hard to address those. Okay. And then the other point I want you kind of realize is that all this kind of distributed system issue is very complicated. So SLEC actually couldn't resolve the issue by their own. Because the DNS is based on Amazon Route 53, and then they also need to talk with Salesforce and lots of DNS community, and then also of course their own customer experience team, because that if you have this kind of large scale unavailability, then customer won't be happy. Then that's what the real world is facing. So if you want to roll out something, you need to be very, very careful. Okay. So the takeaway is that what is DNS attack, and they are like denial of service attack and spoofing attack and some of the solution. But like on paper, solution might work, but like in reality, it is not that easy to just like roll out the service. Okay, that's all I want to share today. Thank you.